Right, so we are now looking at object-oriented programming, which is a development to our procedural or conventional and generic programming. So because we'll be using C++ as our example or our platform for practicing object-oriented programming, we want to first introduce ourselves to how we program using C++. Then after that, we want to move on to the object-oriented programming technique. So object-oriented programming, it's a technique, not a language. There are different languages which are used, but you still be dealing with object-oriented programming. A very good example is Java. It's an object-oriented programming language. But here we are just using C so that we understand what we are dealing with. Let me mute our audio, please. So we look at C++ as a beta form of C, right? So C++ was developed from C programming language, and this was done by adding a few features, right? So there are non-object-oriented features which we can use when you are writing our code, right? And these are not involved with programming technique. So the programming technique is object-oriented programming, but then we can have non-object-oriented programming features, right? Then there are features which support object-oriented programming that are available in C, right? So we are saying you can program in C using object-oriented programming, or you can also use generic programming. That means you program in C++ as if you are programming in C. So in other words, we have a few exceptions, right? The C code that is not C++, right? But most C++ code is also C code, right? So that's why I say
liquefied natural gas to help reduce its reliance on Russian energy.
That's why we are saying C++ will be a superset of C, right? So there are some enhancements that were added to C, which are also non-object-oriented programming, right? So we are saying C++ has other features which are added which are actually enhancements to the C programming language. That means it's just an improvement of the C programming language. That means when we are dealing with the non-object-oriented programming features, these are enhancements, right? But as you write your programs, make sure that you know when you are dealing with object-oriented programming and when you are just dealing with generic programming. So in other words, I said object-oriented programming is a technique. Then you can also use your generic programming when you are now just writing the code. That means when you are activating your objects, you will also be using our generic programming. This will become clear when we go into our examples when you are now dealing with proper object-oriented programming, right? So C++ enhancements to C, these don't have anything to do with object-oriented programming, like the use of comments. This is a multiple line commenting. This is a single line commenting, and it increases readability. That means you can easily follow your program. I think we talked about that when we're talking about C programming. Then there's also an issue of declarations and definitions, where a declaration, it introduces a name which is an identifier, right? So it is saying there will be a function of this form or a variable of this form, and it should look like this. So it's like programming whereby you are introducing a template of your function or a template of your variable. When you use a definition, now you are making the variable into existence, or you are making a function into existence. That means in a definition, that is when memory or space is allocated to your variable. That means when you're now saying this is the variable M, it is allocated memory space. Let's look at the examples. When you say extend int I, because of this extend name or identifier there, this becomes a declaration. Int I, it becomes a definition. When you say int I, memory is allocated to I. When you say extend int I, you are saying there will exist a variable which is an integer and its name is I. It will be an external variable. When you say struct complex T, you are saying there will exist a function called complex T, which will be a structure, right? But then when you say complex T, C1 and C2, you are now defining the function void func. Because of this void, you are saying there will be a void function called func, which takes arguments which are integers. Then when you create the body of that function, you are now defining it. That means you are now taking space, right? So in C, declaration and definitions must occur at the beginning of a block, but in C++, you can put them anywhere as long as you have defined them before their first use, right? So you define a function before you first use it, but you can define it anywhere else. But in C, the first part of the block should be the declarations and definitions. Then a variable only lives in the block in which it was defined, and this defines the scope of a variable, right? So let's look at an example where we talk about the scope of the variable. Int a is equal to 0. For int I is equal to 0, I less than 100, I plus plus. Then we open our block here. A plus plus increment A. I mean, this A is being incremented there. Int P is equal to 12. Because this P has been defined or declared within the block, the for block, once you get out of the for block, this P no longer exists. It goes out of scope, its memory is deallocated. But A will continue to exist. So the variable I is created at the beginning of the for once. So you are creating I here once. Then P will be created 100 times because it's within the block which will run 100 times due to this section there, right? So we can also go on to use what is called the scope operator, which is the double colon, whereby if you say int y is equal to 0, int x is equal to 0, and these are not in any function block, they are global variables. Then you have void f, which is a function f, and you open the block here. Once you open the block, whatever you declare inside there, we have the scope of the f function. So int x is equal to 5, this becomes the local variable, right? It kind of hides the global variable x. But when you want to access the global variable x, you put this double colon, which is your scope operator. Because of that, you will be referring to the variable outside the block. But if you just put x straight away without this double colon, you are dealing with the local variable x. But if you say y plus plus, because there was no declaration of a function of a variable called I in this function f, this will automatically refer to that. Because y has not been hidden, by any other definition of a variable inside the block F. So you only use this when you know that the global variable has been hidden by another definition in the local function. Then you use this when you want to refer to the outside value. I think that makes it clear there. So let's look for an example. Int x is equal to 1. This is our global x because it's outside the block. Then void f, that's our function. We open the block here. Int x is equal to 2. We are defining the local what? The local x. So it's given its space there. Then scope operator x plus plus. We are incrementing this x. Okay. By incrementing what? This x, and the global x is now equal to 2. Right? It is now equal to 2 because of this. If you just put x plus plus, then that x becomes equal to 3 because we are looking at the local variable. Right? Example, int I is equal to 1. This is global because it's outside the block. Then main int I is equal to 2. This is the local. So we have I global and I local. Right? Then you open another block here. Int n is equal to I. It goes outside this block, so it will pick this one. Int I is equal to 3. So our n is equal to I. N takes the value of 2, right? Then int I is equal to 3. We are now hiding this, and now our I is equal to 3 within this scope. So that when we print out the value of I and the value of global I, right? So the value of I without a global operator will be 3 because it is the one which has initially been given there. But the value of global I has not been affected. So the global I is this value outside there. Then we close this block, right? Then we do the same thing. We want to print I. If we print I now, our I becomes equal to this because it's local to this block. Remember, the inside block has been closed. So we are dealing with the outside block. Then global I, we are still going back to this. Right, so I hope we get that explanation about our scope operators. So once you get out of this block, this I and this n no longer exists. We only have this int and that. When you go out of this block, then this I no longer exists. We are only left with that. Okay. So like in C++, the same operator may have more than one meaning. The scope operator has also many different tasks. We'll look at it later when we introduce the terms that we use there. Then we have what are called inline function. In C, macros are defining by the word hash define directive for the preprocessor. So you say hash define maybe x, then you put 10, right? You are saying wherever you refer to x, you are referring to the value of 10. In C++, macros are defined in normal functions. Here, the keyword inline is inserted before the declaration of the function. The difference between normal functions and macros, well, we have not dealt with this, right? And we are not going to deal with them here. A normal function is placed in a separate section of code, and a call to the function generates a jump to that section of the code. Before the jump, the return address and the arguments are saved in memory. Okay, so we have this x as a function, right? And x is a function there. When you make a call, wherever you were, you save the status here, right? The address, so that when you finish with this, you come back. So you make a call to X here, right? You make a jump to the starting point of the function X, you run that function. When you exit there, you come back here where you were and you proceed. Okay. So when the function has finished executing, the return address and the return value are taken from memory, and the control jumps back to the end of the function, to the statement following the function call. That is what I was demonstrating there. The advantage of the approach is that the same code can be called from many different places in the program. This makes it unnecessary to duplicate function code every time it is called, it is executed. So you write your function X here. Then you can call X anywhere else. X5 jumps to X. You go write anything else, X4, it jumps to X again. So you just write your code once and you can refer to it many times as long as it is needed. So what the disadvantage, the function call itself and the transfer of the argument takes some time. In a program with many function calls, especially inside loop, these times can add up to decrease the performance. Well, our sizes of code which we are using in our practice will be very small, so that this disadvantage is actually not of much concern, because we'll be writing slightly smaller programs, right? So how do we have an inline function? Define square as X times X. So you've defined this square. So once you make a call to square, you're actually executing X times X. Inline int square int X, return X times X, comma. This becomes an inline function. In other words, when the function can be written maybe in a single line in the like, you can just write it there and there, right? Rather than making a call to the function. Okay. Inline int marks that return that. It's a single line which you can run. So how do you use an inline function? An inline function is defined using almost the same syntax as an ordinary function. However, instead of placing the function's machine language code in a separate location, the compiler simply inserts it into the location of the function call, right? So JK, whatever, they just are defined some operators over again that J is got marks that inline function marks is inserted there, right? So if you say J is got marks that, it just comes and insert the inline function that you have already created. The decision to make an inline function must be made with some care. One, if a function is more than a few lines long and is called many times, then inlining it may require much more memory than the ordinary function. It's appropriate to inline a function when it is short, but not otherwise. If a long and complex function is inlined, too much memory will be used and not much time will be saved. So you have to look at the trade-offs, whether to make a function inline or to make it a standalone function, which you can make a call to. But if it's a single line function, like what I has demonstrated, you can make it in an inline function. Then you can make a call to it, right? Advantages: debugging, type checking, and readability. It's there where you are using it, so you can quickly check. When you have a function which is standalone, whenever something happens, you have to go back to where the function is and check what is happening there before you can proceed. I think I have to stop here. I have to stop here for the time being so that I can save on my time. Turn it around, let's say 11:30. Then we'll come back and continue from where we left. So I'll stop my recording here so that I don't get timed out while explaining something else. So we ended here on inline functions. Then we'll start from function arguments when we move. Okay, so I'll stop sharing, stop the class for the next about 10 minutes. Then we come back and proceed.